So the multiple components that are being combined into a single component for a variety of different applications in humanoids. Just taking, for example, this is one of our more simpler ones. It's a spherical plane bearing pressed into an aluminum housing, and the housing itself is optimized for weight being one, hence being aluminum, but also the cycle life and the size of the ID of the spherical plane bearing. It's just leaning more and more towards customization, whether it's in size or design. Now, if we take a look at, let's say for like a cross roller, which we would consider this to be one of our more simpler designs, it combines a variety of things like threaded holes, extended flanges, and in terms, and certain times, integration with other parts, like combining a gear on the rear face of the housing that the cross roller bearing would be pressed into, so combining those all into one, just because sometimes the bearings can get so small that you don't have enough space to reach the safety factor of what these bearings are needed. Like a good example would be for contact stresses on the on a cross roller bearing needs to reach or exceed, be able to handle over 4,000. I believe it was newtons, and it just was not possible with a bearing that was so small. Again, it was less than 15 millimeters in OD, and the ID was I believe it was a little bit less than 10 millimeters. So that didn't give us a lot of space to work with in the raceway itself. So we are trying to take a look at now the housing itself, or the mating dimension for the bore, and seeing what we can work with there to maximize the amount of space that we're working with. So sometimes the application can't be solved just with a typical standard design bearing, and that's what we tackle, and that's what has allowed us to be successful in the humanoid industry. Because we don't look at, okay, this is dimensionally impossible, we can't do this. No, we take a look at other things. Okay, so if we can't meet it dimensionally with what the current part or the standard design is, let's see what's around and see if we can integrate it with other things, and if that gives us enough space, then we can go ahead and start manufacturing it, or potentially at least take a look at some CAD and 3D models, and then run an FEA analysis to see if the stresses can be met. So I think integration is a huge thing that we're seeing in the humanoid industry, and it's what's going to allow some of these engineers, design, manufacturing, and mechanical engineers to reach the parameters that they're setting up for themselves.